Hey guys, what's up? Wanted to do a little show and tell here tonight to talk about some of the output of what's been occupying my time the last several months. But before we get to that, I want to tear this down and give you some like really nerdy level details about what's going on in here and what my plans are going forward. But just a quick background before we do that, I just want to say that the only reason I'm even doing this is because I wanted to, I had this idea where I could produce this effect if I could create a camera pan that was repeatable. So, you know, pan the camera the same exact way, exactly over and over, could do some cool stuff. So I naively thought that was going to be something I could do with some pretty simple stuff, and it turned out it's not. So this is kind of the result of the path that's taken me down. So let's take a look at exactly what I got here, what's good, what's bad, and what I plan to do next.
Control basically works kind of like the camera on a tripod.
Yeah, it has the same principle. So if you were trying to make a clone like we've done in a lot of videos before, on a tripod, all you have to do is shoot a person on one side of the screen, then don't move the camera, put them on the other side of the screen, put those two pieces of footage together on top of each other, and crop it.
As long as the background is the same on both sides, you can make that crop seamless.
So we take that same principle and we apply it to a repeatable motion arm that essentially gives us the exact same move from the camera as many times in a row as we want.
So we can do take after take after take, and the camera will always do the same exact thing.
Now that we have two pieces of footage that move exactly the same, we can put them on top of each other and animate the masks so that you can see two people at the same exact time. Or we can just do jump cuts from one shot to the other, and the person will pop from one side of the screen to the other.
And we decided to do both on this short film.
The first prototype I built was a really crappy, you know, in the style and the premise of rapid prototyping. I wanted to just get started and start learning quickly. So the first angle I went for was just mechanically pan a tripod I had with a fluid head on it. So, you know, not a big deal. Attached to the handle that's made for your hand, and just use a little servo and sweep around. Yeah, that didn't really pan out. So that kind of left me with nothing that I could really use for what I had set out to do in the first place. And with nothing going on and not sure what I was going to do exactly next, I decided to at least accomplish something, and then that something was, well, I'll build something that will make my camera move. I can get some camera motion out of. And I found a lot more information on do-it-yourself camera sliders than I did on panning and tilting. All right, so taking the brain box off, I'll break that open in a minute. This is the first prototype I've built where I have some gears driving the shaft to do my rotation work for me. And actually, this is a piece of junk. It's not usable for anything. In fact, I'm going to take the GoPro off of it because, you know, everything from here up basically is friction holding it together. Just a you know, prototype to learn a couple things I needed to learn, which I did learn, and I'm going to talk about when I get to that. I needed to accomplish something because I'd set out to make my camera move, and so a camera slider was the first thing I built. And actually, this turned out pretty good. This product called IGUS, which is this piece here, this rail piece. And these guys make industrial motion control stuff, and people have been using their rail system. Got this, you know, this plastic bearing in here, so it's not an actual bearing, it's just friction plastic on metal. Real smooth action. Lots of people apparently use these for sliders. So I found a great deal on one of those, and then I got on Servo City and found that they had a little kit I could buy. It included this motor, these end brackets, pulleys, the belt, and the instructions. And I also bought these limit switches, which this whole thing ran me about $360, I think, as it sits. And you know what I can do with this, of course, is connect it to my Arduino to control the speed and the distance and, you know, the basic slide functions, which is kind of cool. You know, I see sliders, programmable sliders that can do things like Arduino can help us do online, are selling for $1,400. Some of them you can get into cheaper stuff, but this is pretty solid, pretty quality. I'm very happy with how it turned out, and I could definitely drive some costs out if I were making some of this hardware could be 3D printed, not all of it, but some of it could, and the machine stuff could probably be sourced from somewhere other than where it came from. Could definitely drive a lot of cost out because I paid, you know, over $100 for the hardware kit to go with that. But the most important thing on the slider, and I'll include this information on the online resources I'm going to create to share all the information I learned, you know, these limit switches. And what the limit switches do is you're really simple diode circuit design that allows basically electricity to flow in only the correct direction. So this will only allow the platform to come down and hit the limit switch, and when it does, it'll cut off all the current and not allow any more current to flow in that direction. But when you reverse the current to make the slider move the other way, the diode allows the current to flow in the opposite direction, and it'll move away from that set point. So it's kind of like a hardwired safety mechanism that's really important, because if that didn't happen, then you know your motor could drive into the end of your slider, tear something up. So really important feature. I'll include the diagram and further instructions on this. So that's the deal on the slider. I'm really happy with how that turned out. I'd love to try to drive some costs out of that. I actually did learn a lesson, by the way. I didn't realize and didn't look deep enough into my purchase of this rail, because that was kind of driven by this kit I'd found on Servo City. So I was trying to get the cost down, and I bought a rail that's actually not as wide as what this kit was designed for. So my rail was more narrow, and I actually had to do a little bit of engineering, move some holes around, and a couple other things to make it work. And it's got a lot less clearance than what the kit was designed for it to have, but it still works. That's the slider, and that's what I learned about sliders. It's the piece I'm most proud of, by the way. It's not that this is worth a crap for what I need to do, which is pan the camera, which I said before. It's a piece of junk as far as that goes, but what I did is discovered how I'm going to control better hardware. And I also kind of got narrowed down what hardware I think I really need. The way this came about was I was kind of pondering, you know, what I need to do to fix this. And lo and behold, my buddy JW, the landlord, had an old printer that someone had given him and he wasn't using, and he asked me if I wanted it. I was like, yeah, I do want it. So I took the printer, which I knew would have motors and gears and all kinds of fun stuff inside of it, and it did. And so I took it apart and demolished it. It's over here in a box in a million pieces, and I took the motor and a couple gears out of it and rigged it up to my Arduino so that I could control its left-right. And the biggest problem with that is that the motor and gear stuff that I set up here is is made for a printer to drive paper through the printer, so it's geared pretty fast, and so its slowest speed that it'll do is still pretty quick for what I'm wanting to do. The dream ultimately would be to figure out the right gear ratio and the right configuration, and develop as much of that as 3D printable objects as possible, so we maybe have a panning system. You can double them up and get pan and tilt out of the same exact device. No big deal. But the critical component, the biggest piece I learned out here, the thing I'm most proud about this entire exercise in building this prototype, was this little guy right here. I'll pull the tape. There's nothing to see. The tape's just covering up the connections. It's actually right down in there is where it is. And that little chip right there has a wonderful ability to sense the precise direction of a magnet that's placed close to it. And my magnet, in this case, I just put right here on the end of the shaft that spins when the motor turns on. So basically that little chip allows me to detect exactly which direction that magnet's pointed in, gives me a value out that my Arduino can read, and so then I can kind of program which position I want my shaft to rotate to, and that's how it works. So that's the breakthrough. That's the great news. So I'm proud of the little prototype. Got me where I needed to be. I actually could do some filming with it, but it's still pretty jerky. But I think what I've learned basically is that this hardware problem has been reduced to a single component that I think I can source. I'm going to be looking for that until I succeed. but this little guy right here is going to be where the magic is. And so if the hardware works out as I hope it will, then it will allow me to reduce all the problems to software problems, in terms of, you know, being precise with repeatable stuff, things like that that we need to conquer next. So I'm really confident because of this chip and its capability. 12-bit resolution gives me 4,096 unique addressable positions in a 360-degree spin. So that, in other words, really fine level of detail of data I can tell you about which direction my camera's pointed in. More than enough to be repeatable for what I want. But, you know, a chip with that capability is one thing. Getting that built into a fully functional deal is another. So that's the most exciting thing I think I've learned about panning and rotating cameras, is that you need something like this guy to tell you where you are and tell you how to, you know, will allow you to control set points and do what you need to do. That little chip can be bought, depending on quantity, as cheap as $1, but you'd have to buy like 500 of them to get them that cheap. I paid a lot more than that, and I actually learned a secret after doing that from the supplier, and I'll post a link in the description, but AMS will send you free samples. So you can get some of these for free. If you're doing a hobby project like me, just need a couple of axes. I think I'm going to get 5 of them. I haven't ordered them yet, but because I want to order several different types. They have some that are center axis, some are offside axis, etc. So I'm still shopping around before I take advantage of my free sample chips, but a pretty cost-effective way. And this technology gives me absolutely every reason to believe that that it's possible to build a pretty precise, controlled pan and tilt camera system. I got parts on the way tomorrow. My little prototype will be dead. That's one of the reasons I wanted to make this video today, because this guy's going to come be torn apart and be ever lost and replaced by what's next. And I just went down and bought this little PVC electrical box. Paid like $6. So let's open it up, see what's in here. The Adafruit motor shield. That little board allows me to have a 12-volt supply on my motor and still have 5 volts down on the Arduino, which is running the code behind the thing to make it all work. Really cool, totally worth it. Good product from Adafruit. I'm impressed with those guys. One thing else I should mention is that what else I have learned is that there's not really a lot of information out there on this endeavor. So trying to make an addressable rotating shaft camera thing, you know, you're going to spend $900 and up for systems to do just a single axis. They're really expensive, and nobody's really conquered this on the do-it-yourself sort of independent guy side. So that inspired me, and so what I plan to do is set up a site to publish all the information I've learned, all the code I've written, parts numbers, where to get them, how to supply them, tips, tricks, traps, open source, basically everything I've learned. And I'm going to continue to develop my panning camera, and I hope that there will be other folks out there that are interested in this that will join the party and submit their knowledge and share their information that they learn and help one another. Maybe we can turn this into an open source project. So if you hadn't looked around at what robotic cameras can do, you should really check that out. If you're already a filmmaker into cinematography, I know you already know, and I know you know that the equipment is very expensive. So hopefully this will snowball up and maybe develop into something. I will share all my knowledge, and I hope to see it grow. I hope to see some other folks get involved, because I know that the whole thing could be taken a whole heck of a lot further with other people being involved besides just myself. So that's it for me for now. I'm out. Thanks.